Hello, I'm Murph. Going to go over part two of how an air conditioner works, air conditioner 101 type stuff. I think it's important to be able to name the large components in the system. And so this is just to provide non-technical foundational knowledge for you, so that way you can hold your own in a conversation with someone about an air conditioner or a technician, and you can have a better idea of what they're talking about. So we're going to keep things still very broad, and we'll do a quick recap and then just hit some other major stuff and things that I hear a lot and talk a lot to customers about. So let's just get right back into it. So in part one, we talked about condensers and evaporator coils and the difference. The evaporator coils absorb heat. The condensers outside reject heat. We talked about split systems versus packaged units. Split systems have a box outside and a box inside. Packaged units are one box outside, usually on the roof. So it can be either split or it can be a packaged unit. We talked about the blower motor and its function and how it creates both negative and positive pressure, and it travels, and how the air that it creates goes through the home and goes through a sealed system called ductwork. Ducts, flex duct, hard duct, other types of duct. But that air is a medium for heat transfer and helps the cooling process that way. Talked about capacitors and how they are the number one repair that service technicians make, how they're, in layman's terms, kind of like batteries, and they lose charge over time and they need to be replaced. Otherwise, the motors that they support just will fail and stop working. We talked about filters and why it's important to change them, and how often you should change them depends on a number of circumstances, both inside and outside your control. I want to talk briefly about how you can tell the difference between whether or not you have a heat pump or a furnace. This is a picture of the back plate of your thermostat. The thermostat has a front plate, which is where the digital screen is, and that's the display. You can, I know you might be scared to, but you can rip that off, and then what you're seeing here is the back plate, which is where the thermostat wires connect to. And a common way you can figure out if you have a gas furnace or a heat pump is look at the thermostat wires. If you have a wire going into the W or W1 socket in the back plate of the thermostat, then you likely have a furnace. If it's going into the O or B socket, you have a heat pump. Another way you can tell is if you ever were to go into your attic, or if your indoor portion of your AC system is in a closet or somewhere where you can access it or want to access it. You'll see in this picture there's this kind of sheet metal, flexible metal looking thing. That's the flue, and that discharges gas outside of the home, carbon monoxide, dangerous gas. So air handlers will not have that flue. Furnaces will. And then lastly, you've got something here called a reversing valve. That would be inside the condenser outside. It's got 3 copper pipes on the top and 1 copper pipe on the bottom. So if you just look in your condenser and you see this reversing valve, that means you have a heat pump. So in the same way that airflow from the blower motor moves throughout the ductwork and it's a sealed system, there's copper pipes called line sets that connect your condenser to your air handler or furnace, and that is what refrigerant travels through between the outdoor unit, the condenser, and the indoor unit, which is the air handler or the furnace. So the refrigerant is like air, a medium that helps with heat transfer. So just be aware that especially if you have a split system, there's copper tubes called a line set, that two of them specifically, a suction line and a liquid line, that travel from outside through your walls up into your attic or into your closet. It connects the two units, and that's why it's one system, even though it's split between the outdoor portion and the indoor portion. And again, if you have a packaged unit, the line set is extremely small and confined to the one box that everything is in. So we're not talking 15 to 50 feet of copper tubes. We're talking, just a few feet within that one box, and that's where all of your line set is if it's a packaged unit. So this is a picture of your evaporator coil that's located inside your air handler or in your furnace, typically if it's a split system. You can see it's gray. It's got like little micro fins, and refrigerant, like through the line set, also travels through both the evaporator coil and the condenser coil. And water forms on these coils, and that's normal. When humidity comes across it condenses into water, hits the black drain pan on the bottom, and then flows through PVC pipe. That PVC pipe is called a condensate drain line, and it's normal for water to flow through there and to the exterior of the home. We want the drain line, the condensate drain line, to exit somewhere where it will not be a hassle to the homeowners or to anyone. So it's often you just walk by it, you have no idea what it is, and but it's dripping water a lot. What can happen is as water forms on the evaporator coil, it will pick up dust, debris, particles, dog hair, whatever's inside the home that gets sucked in through the ductwork and past the filter. It will collect on the evaporator coil, and so then when water forms on the evaporator coil, it will pick up all of that stuff and drop it into the drain pan. The water will move it into the condensate drain line, and that stuff can form a restriction, which will then keep it from water from flowing, and you could basically clog up that drain line and get if the water can't exit there, it will just back up, and you'll have a lot of standing water in that drain pan right where the evaporator coil is located. And where this comes into play is something called a float switch, which is this right here. It's a P-trap with a 24-volt switch cap on the top. It's that black cap on the top. That will turn off the thermostat when it senses water is not flowing anymore through the condensate drain line. So that will turn off power to the thermostat. So if you have a thermostat that is going blank on you, a lot of customers, homeowners feel like that it's a problem with the thermostat, when in fact it's actually a restriction in their condensate drain line. So it's really good to have a float switch and a P-trap on your condensate drain line, so that way you don't suffer water damage, because if the float switch does not turn off the unit, more water will form, and then it will just overflow out of the drain pan in your attic or wherever your indoor section of your unit is. So what you can do if your thermostat's turning off is something that is you could just troubleshoot and see if it will fix the issue for you, is just take a shop vac, put it in the sucking setting so that it sucks air, connect it to wherever the exterior drain is on the home or the structure, and use a hand to seal it, or use some tape, get that thing really sealed, and just turn it on for 5 to 10 minutes and try to clear the restriction by sucking out whatever is restricting the drain line. That is something that you can do. I do it as a technician whenever I get a call for thermostats turning off. A lot of times it's the restriction, a clog in the condensate drain line, and you can see you can get all this gunk out. and it will turn your thermostat back on. Hope you learned something from this. We covered a little bit more about the air conditioning system and some key components in it and how it works. Hopefully you feel like you're a little bit more armed, you gained some knowledge, and it wasn't overly technical or overly difficult to grasp. I tried to keep it very simple, but I'll put out some more videos if this is helpful. I hope you have a great day, and thanks so much.